Okay, so let us start. Very few have joined, but still, good afternoon. Okay, very few joined. So, okay, whatever is. So basically, we have started chapter number 6, which you can see on your screen. The suspension system and modern trends in automobile. That is the present chapter which we are discussing. Before moving ahead, can somebody confirm, unmute and confirm that my voice is audible and my screen is visible for them? Can somebody? Prajakta, can you confirm?
Yes, sir, audible.
Yeah, and the screen is also visible?
Yes, sir.
Okay, thank you. Thanks for confirmation. So let us proceed. So basically, this is the chapter which we are presently going to discuss about, and discussing basically we have started in the previous lecture. So the suspension requirements, the title of this particular chapter is Suspension System and Modern Trends in Automobiles. As I have told you, this particular chapter is constructed by combining earlier two chapters. So one chapter was the suspension system and other chapter was modern trends in automobile. So both this contents has been combined into one chapter, and they have now here. So starting from here, suspension requirements, sprung and sprung mass, types of automotive suspension systems, conventional and independent suspension, shock absorber, types of springs, Hotchkiss drive, torque tube drive, reaction members, radius rod, stabilizer bar, and air suspension system. Up to this, we have the chapter for suspension. And here onwards, engine electronics module, introduction to sensors and actuators used in automobile controls, electronic control unit, traction control devices, fuel cells, electric vehicles, solar vehicles. All this is a modern trend chapter, earlier chapters. Now they are combined into two. So the suspension chapter, uh, we have here, we have a weightage of out of that 8, whatever is seen in the syllabus, we have almost 5 chapters, 5 hours dedicated for this particular chapters. 4 to 5 hours will be required, out of which 1 hour we have already discussed. Now 3 to 4 hours will be required. So let us see how we are going to proceed. Moving ahead. So here we have your vehicle, and you can see over here something beneath the axle. This is your front axle, and here the spring system, etc. Okay, sorry, above the axle, that is here and here, here and here. So this basically is your suspension system. Okay, so what is suspension system? Here we want to isolate the shocks. Already we have discussed the some part of the requirements and functions of suspension system, and one was to isolate the shocks. So here, whatever shocks is being received by the wheel tire assembly, we don't want to transmit it to chassis, because if it is transmitted to chassis, it will be transmitted back to the passenger compartment. In other words, the shock is reaching to passenger, which we don't want, and therefore we want to isolate it here, and that is where the role of suspension system is coming into picture. So these are the basic functions of a suspension system, which you can see on the screen now. So the suspension system performs following functions. Maintain correct vehicle ride height, means suppose the vehicle is moving at a certain height like this, then it should not move down or up. Okay, it should not move down or up. So we want to ensure that whatever the ground clearance is being designed. So in general, we know that for off-road vehicles, that is the vehicles which are used in rural areas where there is no paved roads, we keep the ground clearance more, and for paved roads like in city vehicles we keep the ground clearance less, because on a paved roads we consider that the less obstacles are there, the roads are more plain compared to the rural areas, and that is where we have the requirement of maintaining the correct vehicle height with respect to the ground clearance is coming into picture. Reduce the effect of the shock forces. So whatever the shocks received by the wheel should not transmit it to driver. Maintain the correct wheel alignment. So if the vehicle is moving like this, then it is going to contribute to the discomfort of the passengers as well as drivers. And moreover, we know that the wheel alignment is going to be affected by when the wheel is moving from its position. Okay, so whatever position it is supposed to be there, it has to be there. If it moves away from that particular position, then in some way, that is, suppose this is your wheel, and if it moves up, so you can see it is going to be tilted. If it is going to move down, it is going to be tilted like this. So the angle, you can see the angle is going to change. That means your alignment geometry is going to be changed. Support the vehicle weight, that is another thing. So yesterday when we discussed in the previous lecture, we said that whole weight is finally borne by the air inside the tire. Okay, so that is where when the vehicle there is no air in the tire, the wheel completely gets deformed. Okay, why? Because the whole weight is coming there on the tire, and if there is no air in the tire, there is no component which is going to bear the weight of the vehicle, and the vehicle weight in terms come into the rubber part, the flexible part of the tire, and that is where the tire gets deformed and damaged when the air is less. Keep the tire in contact with the road. So we have a certain amount of contact requirement as per the design in case of wheels, sorry, the tires and the road. Suppose for example, a highly inflated tire will give you a contact like this, and a less inflated tire will give you a contact surface like this. Correct. So this is more inflated, this is less inflated. Okay, we don't want either more inflated or very less inflated. We want a equilibrium or balance in between. Okay, we want a optimum tire contact. So that is where the tread comes into picture. So there is something called as a tire tread, which we have discussed in the chapter number 1. So specially designed area where the tire should be in contact with the road. Okay, if the side part of the that is this particular side of the tire is coming into contact, then this is going to wear very fast, because this area is going to have higher tread area is going to have higher wear characteristics when compared to this, because the side walls are generally designed for flexibility. They are not designed for wear. Okay, and therefore that has to be taken into consideration. Control the vehicle direction of travel. So these are the basic functions we have already discussed. Moreover, we have discussed this particular things also in the previous lecture. That is our sprung and unsprung mass. So what is the sprung mass? The sprung mass is the mass which is supported by the springs. That is called as a sprung mass. Okay. So the vehicle springs carry certain weight on it. It is a spring, and obviously being a spring, it deforms when loaded. Okay, so that particular weight which is borne by the spring is what you call as the sprung mass. Okay, or sprung weight. And that weight which is coming below the spring, which is not supported by the spring, is called as a unsprung mass. So here you can see this part is the unsprung mass, and here this particular part which is above the spring is what you call as a sprung mass. And that means the sprung mass and the unsprung mass is separated by the suspension springs, or in other words, suspension system. So the suspension system differentiates or separates the whole vehicle weight into two parts: the sprung mass which is above it, and the unsprung mass which is below it. So in this particular case, we have shown two coil springs where it is a coil spring type of suspension, while here it is shown one coil spring and one V spring. So this is a leaf spring suspension and this is a coil spring suspension. So there are different types of suspension based on the type of the springs used. And in this particular suspension, it is shown a coil spring. So this is a coil spring suspension. And here we are using leaf springs. So it is a leaf spring suspension. So in other words, we call this particular type of suspensions as conventional, and this is the independent type of suspensions we call them in general. In the sprung weight, we have the body, frame, powertrain, and so many other components. Okay, and in the unsprung weight, we have the tire, wheel, brakes, bearing, axle, differential, etc. So all the things coming over here, that will be the unsprung mass or unsprung weight of the vehicle. Now, axle vehicle jounce or rebound. So how the vehicle rebounds? So which motion is what we call as a rebound type of motion? Okay, jounce or rebound type of motion. So this is your vehicle. Okay, and now you can see the distance of this particular, here the suspension comes in between. So due to suspension, the axle is moving away from the body and it is coming nearer to the body. So such a motion, vertical motion, is what you call as a jounce or rebound. Okay, so it is moving up or it is moving down. Okay, so when it moving up, the spring over here gets compressed, and when it is moving down away from the body, the spring gets extended. So spring is getting compressed or getting tensed in between the body or the frame and your axle. Okay, because the suspension system is located in between these two. Okay, so at a normal ride, it is at a optimum distance. Okay, and during jounce means when it is moving up, it is nearer. During rebound, that is when it is going down, it is moving away from the frame. Okay, so jounce and rebound. So one is jounce and rebound. So that particular motion, okay, totally called as a bouncing. Okay, so this is one type of motion which is allowed by the springs or the suspension system in all. Now the next type of the motion which is being taken care by the suspension system is the vehicle rolling. So rolling means when the vehicle is moving like this or this, so that is your rolling. Preferably you can experience the rolling when the vehicle takes a turn. Okay, so you can see on the one side it moves up and the other side it moves down. Okay, so such a way condition is what you call as a rolling. Okay. Now here there are two conditions mentioned. 1 minute. Here the body is rolling, axle remains the same. Okay, comparatively axle is stable while the body is rolling, so we call this a body roll. And we have seen many times vehicle with the independent suspension, tire असं वरती खालती मूव होताना दिसते पण बॉडी हाय तिथंच राहते. Okay, so the suspension system is taking all the shocks. At that time, if the axle tilts like this but body remains the same, we call it as an axle roll. In all, we call it as a rolling motion of the vehicle. So on the horizontal axis like this, the body is moving like this or this. Okay, so that is your rolling. So on this axis, if it is moving like this, then it is your rolling. And on the vertical axis, if it is moving up and down like this, then it is a bouncing. So these are the two important things which are supposed to be. Other than this, there is your so many types of motions are there. As and when required, we will see them. So this is the most important two types of the motion which has to be taken care by the vehicle, because we know that there are three axes. So we have just discussed one axis. We can have this type of motion, that is front going down and rear coming up, or rear going down and front coming up. Okay, or we will have the third axis also. Okay, so here this is a vertical axis. We can have the motion like this like this or this. Okay, so all such motions are there, and all the things has to be taken care by the suspension system. And in general, we have two general classification of suspension system, that is rigid axle or conventional axle suspension, rigid axle suspension or conventional axle suspension, and independent suspension. Okay, we call it as live axle suspension also. Okay, sorry, not live axle suspension, we call it as an independent suspension. So this is a rigid axle suspension. The name itself is rigid axle. Okay, so the name indicates that the axle is rigid one. Here it is not so. Okay, so here you can see the independent suspension and the rigid axle suspension, how it behaves. For example, here you have this particular independent suspension. So in the independent suspension, what is expected is that every wheel is independent to move on its own whenever it receives the shock. Whenever the shock is received by the wheel of a particular side, may it be front or rear, that particular wheel on its own will take care the shock. It is not transmitting that particular shock to the chassis. So you can see in this particular case, the axle remains horizontal only, but this particular spring is getting compressed when this particular wheels goes on a bounce, or that is on some obstruction and it is moving up. Okay, so when the right wheel is moving up, okay, so you can see the spring on the right side is getting compressed and that particular wheel is moving up, but this particular tilting of the wheel is not affected on the chassis. The chassis has not been tilted, so the chassis size remains as it is while the wheel is moving up and down as and when it encounters a hump or a ditch, or bump or a ditch. So something protruding out, we call it as a bump. So if some obstruction is there like this, then it is going to move up when it is reaching over here. At this particular position it was here, but when it comes over here it is moving up. So that particular motion is not transmitted to the chassis in case of independent suspension. That is why it is called as independent. While here this is called as a non-independent or rigid suspension. Why? Because here the wheels are on the same axle, rigid axle. So whenever one wheel goes down, the wheel is tilted, or any particular wheel goes up, the axle is going to tilt it. And when the axle is being tilted, the vehicle itself is going to tilt. Okay, so whatever the motion of the wheel during a bump or a ditch, okay, that particular motion is going to tilt the axle in case of a rigid axle suspension. While here the axle is not going to be tilted, okay, it is going to, so this is your axle over here, and that axle is not going to be tilted, while the suspension spring is only going to be affected, and it is getting compressed, and in the process of compression it is taking that particular shock. Okay, and the wheel itself is moving. So whenever wheels encounters a bounce or a ditch, it goes in a ditch, at that particular time the wheels moves up or down, but that particular motion of the wheel is not affecting any way to the on the axle of the vehicle in case of independent suspension. While in a dependent or a non-independent type of suspension, or in other words the rigid axle suspension, the axle itself is getting tilted like this, and therefore it is called as a rigid axle suspension, which is a disadvantage. Okay, so whenever in a bump, whenever a particular wheel encounters a bump or a ditch, at that time the axle is going to be get deflected. Okay, so this is how axle is, solid axle is. So here we call it as a solid axle. Preferably we see such solid axles in trolleys of the tractors. ट्रॅक्टरच्या ट्रॉलीमध्ये आपण बघतो असले रिजिड ऍक्सल सस्पेन्शन असतात, बरोबर. म्हणून बघा ट्रॉलीमध्ये आपल्याला जास्त धडधड का जाणवते, कारण आपल्याला माहिती आहे थोडी जरी ट्रॉली आणि ट्रॉली पलटी होण्याचं पण प्रमाण खूप का जास्त आहे, तर त्याचं कारण मेन हीच आहे की रिजिड ऍक्सल सस्पेन्शन आहे, रिजिड ऍक्सल सस्पेन्शन आहे, बरोबर. आणि रिजिड ऍक्सल सस्पेन्शन असल्यामुळे काय, एखादं जर थोडंसं वरती केलं तर दॅट इज गोइंग टू टिल्ट युअर axle, and when axle is going to be tilted, since we have mounted the vehicle on the axle, okay, the frame is mounted on the, or chassis is mounted on the axle, the chassis is going to be tilted. When the chassis is going to be tilted, the vehicle is going to be tilted. Okay, so whole vehicle body is going to be tilted in case of dead axle or rigid axle suspension. Preferably the rigid axle suspensions don't or they are dead axles. Now what is the difference between a dead axle and a live axle? Dead axle is that axle which is not transmitting any power or torque through it to the wheels. ज्या axle मधून wheel ला torque जात नाहीये त्या axle ला काय म्हणायचं, dead axle. त्याच्यामधून पॉवर पुढे जात नाहीये, परंतु त्या axle मधून जर पॉवर आपण wheel ला ट्रान्समिट करत असू, then it is called as a live axle. म्हणजे पुढच्या बाजूचं जे ऍक्सेल आहे फोर व्हीलर मध्ये, ज्याला आपण डिफरन्शियल कनेक्ट केलेलं नसतं, ते डेड ऍक्सेल जनरली असतं. आणि मागच्या बाजूचं जे ऍक्सेल असतं, वी आर ट्रान्समिटिंग द टॉर्क टू द डिफरन्शियल, अँड फ्रॉम द डिफरन्शियल थ्रू ऍक्सेल्स, हाफ ऍक्सेल्स, वी ट्रान्समिट द टॉर्क टू द व्हील्स, and therefore the power is getting transmitted through the axles, and therefore we say the axles are live. Okay, they are rotating. Okay, they are transmitting the torque to the wheels. So we have dead axle and live axle. So here we are talking of a dead axle. So this is your dead axle, where here there will be some bearing, and the bearing will allow it to rotate freely, but the axle is not rotating on its own, or in any way it is not transmitting the power also. So that is it is a solid axle as well as it is a dead axle. A solid axle does not drive the wheels, so that axle which does not drive the wheels are called as dead axles. In independent suspensions, that is when we call it the two types of another type of classification of the suspension is the conventional suspension and independent suspension. Okay, a general classification. So in a conventional suspension, we preferably go for the leaf springs, and in independent suspension, we preferably go for coil springs. So now we are talking of the independent suspension, allows one wheel to move up and down. So it is something like this. This is a part of, you can see over here. This is a part. Okay, this is a yoke, and there is another yoke with a stub axle. Now the wheel is going to move like this. Now the wheel is going to move like this. Correct? So this is your wheel. This is your wheel connected over here. And here you have the kingpin. Here you have the kingpin. So here you have the kingpin. Here, kingpin. Okay. So around the kingpin axis, the wheel is going to move like this. Correct? As well as it can be moving like this as and when it goes up or down. Okay. So that is how we have a dead axle, and so allows one wheel to move up and down with minimum effect on the other wheel. So in case of a independent suspension where there is a spring over here, okay, it will be connected like this or this, and whenever the wheel goes up or down in a ditch, so in this particular case you can see here, okay, or just now we have seen in here independent suspension. Here what we have, here we have one member, okay, and in this particular member and rigid axle we have the spring. So when this wheel is free to move up and down independently, and therefore this particular suspension is called as independent suspension. So what is the difference between the conventional suspension and independent suspension? In conventional suspension, we use the rigid axles, where preferably whenever the one particular wheel goes in a ditch, that will result in tilting the axle, and whenever the axle is being tilted, the vehicle itself get tilted. Okay. On the other hand, in independent suspension, it is free to move up and down on its own, and therefore whatever the shocks are coming, it will be taking care on itself, and any motion up and down motion, it will not be transmitting back to the chassis or the axle, and therefore the axle generally remains horizontal, and therefore the body is not affected by the up and down motion of the wheel. Okay, so that is where we call it as independent type of suspension. Okay, so that is independent suspension. Each wheel is attached to its own suspension unit. So here we have a separate suspension unit for each wheel, okay, which is working independently of other suspension. Now, why we are saying in terms of independent suspension, we are talking of like this, because in this particular case, you can see here also there is suspension. Here also there is suspension. But even though there is suspension, whatever change in the height of this particular suspension, that is going to affect this particular suspension also, because the whole axle itself is getting tilted. So in independent suspension, it will not happen like that. Any wheel moving up and down, that will not affect in any way on the chassis in general. So the movement of one wheel does not cause the direction movement of the wheel on the other side of the vehicle. So one wheel moving up and down will not affect the other wheels. So that is where we call it as independent suspension. And non-independent suspension or rigid axle suspension, as we call it as, okay, rigid axle suspension or non-independent suspension, both left and right wheels are attached to same axle. We have just seen. Okay, so we have seen it here. It is on same axle. Okay, here it is. So when one tire hits a bump in a road, upward movement causes a slight upward tilt of the other wheel also. So when this wheel is going to move like this cannot stand like this. Since the axle itself is getting tilted, this has to tilt like this. ओके, असं नाही की ही व्हील फक्त वरती गेलं आणि ही हायतच राहील, असं होऊ शकत नाही, कारण हे दोन्ही एका ऍक्सेलने कनेक्ट केलेले आहेत, बरोबर. सो सिन्स बोथ हॅव बीन कनेक्टेड बाय सेम ऍक्सेल, when one wheel goes up, this cannot stand like this, it has to tilt like this, or when this goes up or down, it is also tilted. So this will be tilting like this. Okay, so anyone moving up and down, that will be affecting the other side also. So that was about independent suspension. Here we can see the difference between coil spring suspension and leaf spring suspension. Okay, So this is another suspension classification on the basis of types of springs used. Okay, so here we have coil spring used with the suspension, and therefore we call it as a coil spring suspension. Here we use this particular violet one. Here violet one. Okay, this leaf springs. Okay, we are using, and therefore we call this as a leaf spring suspension. So here the type of spring is the coil spring. Here the type of spring is used is leaf spring. So that was about the classification on the basis of types of spring. Coil spring is most commonly used spring for in modern vehicles. In modern vehicle, we generally prefer to use coil spring. Leaf springs are now limited to rear side in some of the cars. It is becoming slowly becoming obsolete, even though it is less costlier, because compared to the independent suspension, it has so many disadvantages. Okay, we'll be discussing what are the advantages and disadvantages in detail. So these are some of the components with respect to the suspension system. Okay, when we have this is a rod. Okay, we will be discussing about the tie rod, panhard rod, and also many things which are connecting to suspensions. Then we have the subframe, which is connected to your suspension. So on this particular subframe, we have the your main frame of the vehicle mounted. This is your wheel rim, becomes a part of a suspension system. Then we have a damper. So yesterday we have seen, we have discussed that suspension system generally consists of a spring and a damper. So a suspension bush is something like this. Then we have the total independent suspension looks something like this. We have a knuckle, we have a tire, we have the wheel assembly over here. So this is your wheel side, okay, with the bearing on it. These are the springs used, different types of springs we have to use. We have also discussed about some joints they required in case of the suspension system, where we said that we want constant velocity joint. कारण आपला जेवढा ऍक्सेल फिरेल तेवढा व्हील फिरलं पाहिजे. म्हणजे असं नाही की ऍक्सेल 100 वेळा फिरलं की तुमचं व्हील 50 वेळा फिरायचं, असं नाही चालणार, किंवा 98 वेळा फिरायचं असं पण नाही चालणार. सो व्हॉट एव्हर द टाइम्स द ऍक्सेल रोटेट्स, same time your wheel also has to rotate. So that is where your the role of the constant velocity joints comes into picture. Then we require so many shock absorbers. Okay, sorry, springs. So one of the type of the spring is the rubber springs. So we'll be discussing in detail about this springs later. Then we have some part which we call as a control arm, which is a movable part. Okay, control arm. So here, this particular part which is connecting the wheel through springs to the vehicle, it is a control arm, movable lever that fastens the steering knuckle of the vehicle. So this is your control arm. Okay, so here the lower one on the upper side. Okay, many times instead of connecting to the upper side, it will be connected directly to the chassis. So this is your control arm. Then we have the bushings. Wherever these control arms are connected to the wheel or to the frame, there we have some bushes. So you can see the different bushes used. Control arm assembly. So this is your control arm assembly. This is your wheel, okay, with a bearing on it. So this location for the bearing, and this is your lower control arm, okay, and upper control arm, and a spring in between the two. Spring in between the two can be connected like this. So we have a ball joint. So earlier also we have discussed that either it can be connected to a kingpin like this, or a ball joint like this. Okay, so here there will be ball, here there will be ball, okay, like something like this it will be. Okay, here there will be ball, here there will be ball, here there will be ball, and around this particular ball joint axis, the two balls, center line of these two balls. Okay, that is your steering, called as a steering axis, and your wheel is going to rotate around this particular steering axis. So swell joint that allows the control arm and steer knuckle to move up and down and side to side, this is what you call as the ball joint here. The spring, obviously we require many types of spring. We'll be discussing what are the different types of springs. Then we have the ball joints. So here it is clearly shown the ball joints in case of suspension system where there is no pivot pin. Okay, so this is a ball joint. So the here this is a inclination, axis inclination. Okay, so steering axis inclination we have discussed earlier. So it is the center line of this and this. Okay, this is a one ball joint and this is a ball joint. So it is something like this, and it is going to move like this. Okay, this is where your suspension ball joints coming into picture. And we have the damper assembly. So this is your damper with the spring and all. We will be explaining in detail what this damper is. Then we have a shock absorber with a damper in it. So basically, we said yesterday, your suspension system consists of a spring and a damper. So we require some dampers. So as the name indicates, it damps the vibration, keeps the suspension system from continuously to bounce after compression and expansion. Means initially the spring is going to take a shock, and if it is not restricted, that spring may keep on moving like this. कारण त्याला shock भेटला. एकदा का spring ला shock भेटला की ती spring अशी 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 move होत राहते. Unless we prevent it, we damp it. The vibrations has to be damped, and that particular damping work is being done by your damper. So this is earlier, whatever you are in the previous slide you have seen is the steering axis inclination with a ball joint, and here you are seeing a kingpin. तर इथं किंगपिन दिसते बघा तुमच्या, बरोबर. इथं तुमचे असे जोडले किंगपिन, आणि हे इथं म्हणजे इथं तुमचे हे किंगपिन आहे, आणि आता इथं तुमचं व्हील ह्याच्यावरती तुमचं व्हील जोडलंय असं. ओके, सो अराउंड दिस पर्टिक्युलर किंगपिन and this is your axle. This is your axle. So something like that arrangement, or sorry, the wheel. So here you have the control arms, upper control arm and lower control arms connected to the upper joint and lower joint of the kingpin. Steering knuckle. So this particular region where around the kingpin, where the wheel is going to steer, wheel is able to steer, this is called as steering knuckle. So here the wheel is connected. So this particular part is called as steering knuckle. And this is how your damper look like. So damper in a suspension system looks like this. We'll be discussing in detail regarding how it is going to work. So it should react very quickly as per our requirement, and it should not leak because it has some oil in it. Okay, and it check out. Okay, before moving ahead, let me check one thing. So we'll see this particular video.
सस्पेंशन सिस्टम का काम क्या होता है? तो ऑटोमोबाइल में यूज होने वाला सस्पेंशन सिस्टम डायनामिक कंडीशंस में, जैसे कि जब व्हीकल हाई स्पीड
Are you able to hear it?
व्हीकल को शार्प कर लेना हो, जब ब्रेक
Hear the explanation?
टाइम पे ये व्हीकल
Can anybody confirm me?
कराता है. इसके अलावा अगर हम लोग बात करें तो सस्पेंशन सिस्टम में हम लोग शॉक एब्जॉर्बर्स का यूज करते हैं। अब शॉक एब्जॉर्बर्स क्या करता है कि
Can
rough
anybody
road
confirm that
conditions में ये
the
shock
video
को
sound is
absorb
audible to
कर
you?
लेता है, जिसकी वजह से क्या होता है कि जो व्हीकल का मेन फ्लोन है उसमें शॉक नहीं लगता है। अब इसकी वजह से ये होता है कि जो राइडिंग एक्सपीरियंस होता है वो स्मूथ होता है, राइडिंग स्मूथ होता है पैसेंजर्स के लिए भी और लगेज के लिए भी। अब सस्पेंशन सिस्टम के टाइप्स की बात करते हैं तो सस्पेंशन सिस्टम दो टाइप्स का होता है, एक होता है डिपेंडेंट सस्पेंशन और दूसरा होता है इंडिपेंडेंट सस्पेंशन। तो फ्रेंड्स डिपेंडेंट सस्पेंशन को समझाने के लिए मैं
So this is your dependent and independent
एग्जांपल
suspensions.
और इंडिपेंडेंट सस्पेंशन को समझाने के लिए फॉर्मूला वन कार का एग्जांपल लूंगा। उससे पहले ये जान लेते हैं कि सस्पेंशन सिस्टम के कंपोनेंट्स क्या क्या होते हैं। सस्पेंशन सिस्टम का पहला कंपोनेंट है नकल। नकल व्हील हब्स के ऊपर में माउंटेड होता
So
है।
this is your knuckle,
नकल की हेल्प से
where
और
we are connecting the wheels.
सस्पेंशन करेक्ट होता है। इसके लिए बहुत सारे लिंकेजेस का यूज किया जाता है। नकल के साथ में QP और कैचर एंगल्स का यूज किया जाता है, जिसके हेल्प से
So here, this is the location where you are connecting the pin, kingpin.
और फ्रंट व्हील के राइट फॉरवर्ड डायरेक्शन में स्टीयरिंग होने की वजह से पूरे व्हीकल का भी स्टीयरिंग होता है। नकल सेंट्रल बेयरिंग को फोर्सिंग प्रोवाइड कराता है, जिसके
So on the knuckle, we have the bearing on which the wheel is being mounted.
नेक्स्ट कंपोनेंट है स्प्रिंग।
So we are using different types of springs,
कंपोनेंट होता है जब कार
which takes the shock.
एंड बम्प्स को एब्जॉर्ब कर लेता है। अब ज्यादातर कार में 4 स्प्रिंग्स का यूज किया जाता है, जो इसे डिजाइन किया जाता है इस तरह से ताकि वो कार के लाइफ टाइम तक यूज किया जा सके। अब
Can somebody confirm that you are able to hear the video sound?
नेक्स्ट कंपोनेंट है शॉक्स, जिसे हम लोग शॉक
कोणीतरी रिस्पॉन्ड करत जा रे बाळांनो, म्हणजे मला समजतं काय, whether I should explain or you are able to hear.
के साथ मिलकर काम करता है और जब व्हीकल मोशन में होता है
Can somebody chat and confirm?
मिनिमाइज कर देता है। नेक्स्ट कंपोनेंट है स्ट्रट। स्ट्रट शॉक्स एंड स्प्रिंग को ज्वाइन करने का काम करता है। इसके अलावा ये व्हीकल के सस्पेंशन को स्ट्रक्चरल सपोर्ट प्रोवाइड कराता है और जो शॉक अब्जॉर्बर और स्प्रिंग है उसका फंक्शन जो होता है वो स्ट्रट की हेल्प से ही होता है। अब जो स्ट्रट्स एंड शॉक्स दो कंपोनेंट हैं ये सस्पेंशन सिस्टम के बहुत ही क्रिटिकल कंपोनेंट होते हैं, क्योंकि जो Are you someone who uses Microsoft Excel at your home? If yes, then I can help you save up to सिस्टम का मेन फंक्शन है, यानी कि जो शॉक एब्जॉर्प्शन है वो ज्यादातर इन दोनों कंपोनेंट पे ही डिपेंड करता है। नेक्स्ट कंपोनेंट है एंटी स्वे वाश। तो एंटी स्वे वाश को सस्पेंशन सिस्टम में यूज किया जाता है क्योंकि जब व्हीकल मूविंग पोजीशन होता है, जब वो मूव कर रहा होता है उस समय पर एंटी स्वे वाश व्हीकल को स्टेबिलिटी प्रोवाइड कराता है। ये बेसिकली एक मेटल बार होता है जो कि सस्पेंशन के डिफरेंट टाइप्स को आपस
Is connected between the two suspension.
वाइब्रेशन से बचाना, उसको शॉक से कम करना। नेक्स्ट कंपोनेंट है बॉल जॉइंट्स। व्हीकल के सस्पेंशन को इस तरह से
So the
डिजाइन किया जाता है
ball joints are
जब
connected
व्हीकल
over here.
मोशन में हो, उस टाइम पे सस्पेंशन का आसानी से अप एंड डाउन मूवमेंट हो। ऐसा करने के लिए सस्पेंशन को स्पिंडल के साथ बॉल जॉइंट के हेल्प से कनेक्ट किया जाता है। बॉल जॉइंट बेसिकली बॉल एंड सॉकेट जॉइंट्स होते हैं जो कि सस्पेंशन को अलाउ करते हैं मल्टी डायमेंशनल मूवमेंट। अब बॉल जॉइंट को ग्रीस के हेल्प से लुब्रिकेट किया जाता है और ये शील्ड होता है। नेक्स्ट कंपोनेंट है स्पिंडल। स्पिंडल सिस्टम का एक इम्पोर्टेंट पार्ट होता है जो कि व्हील एंड टायर को व्हीकल के स्टीयरिंग सिस्टम के साथ जोड़ता है। अब मोस्ट ऑफ द व्हीकल में स्पिंडल फ्रंट में सिचुएटेड होता है और ये एक तरह का शॉर्ट एक्सल होता है जिसे यूज किया जाता है व्हील असेंबली को व्हीकल के साथ जोड़ने के लिए। अब सस्पेंशन सिस्टम के वर्किंग की बात करते हैं। जैसे कि मैंने आपको पहले बताया कि ये दो तरह के होते हैं, डिपेंडेंट सस्पेंशन और इंडिपेंडेंट सस्पेंशन। सबसे पहले ये बात करते हैं डिपेंडेंट सस्पेंशन के बारे में। डिपेंडेंट सस्पेंशन को समझाने के लिए हम इंडिया में यूज होने वाले ट्रक का एग्जांपल लेंगे। तो सबसे पहले हम ये समझ लेते हैं कि डिपेंडेंट सस्पेंशन सिस्टम में कौन कौन सा पार्ट्स कहाँ पे लगा होता है। ठीक है, तो जो ट्रक होती है जो कि डिपेंडेंट सस्पेंशन यूज किया जाता है, तो जो फ्रंट के दोनों व्हील है और जो रियर एंड के दोनों व्हील है वो आपस में सॉलिड एक्सल के हेल्प से कनेक्टेड होते हैं। यहाँ पे मैंने येलो एरो से सॉलिड एक्सल को दिखा रखा है। अब इससे होता यह है कि जैसे भी ट्रक मूव स्लाइटली लिफ्ट करता है तो सेकंड व्हील है उसकी फ्रंट एंड का या फिर रियर एंड का, ठीक है। अब आगे बढ़ते हैं। तो अब क्या होता है कि जो फ्रंट के दोनों व्हील है और रियर एंड के दोनों व्हील, तो ये चारों व्हील या 6 व्हील जितने भी हो सकते वो आपस में सॉलिड लाइफ एक्सल के हेल्प से कनेक्टेड होते हैं। यहाँ पे मैंने सॉलिड लाइफ एक्सल को आपको कैलवार से दिखा रखा है। अब क्या होता है कि जो सॉलिड एक्सल है और जो फ्रेम है वो आपस में लीफ से कनेक्टेड होता है। ये आप देख रहे हो, ये है लीफ स्प्रिंग। अब लीफ स्प्रिंग क्या करता है ये मैं आपको आगे इस वीडियो में बताऊंगा। अब हम लोग एज्यूम करते हैं कि ट्रक जो है वो रोड पे चल रही है और उसके लेफ्ट टायर के साइड में बम्प आया है, रोड बम्प आया है। इस रोड बम्प की वजह से क्या होगा कि जो ट्रक का लेफ्ट टायर है वो हल्का सा लिफ्ट अप होगा, वो हल्का सा उसका अपवर्ड मूवमेंट होगा, ठीक है। अब इससे क्या होता है कि रोड बम्प के आने की वजह से जो हमारे व्हील का अपवर्ड मूवमेंट हुआ है उसकी वजह से सॉलिड एक्सल है जो कि मैंने से दिखा रखा है। अब ये सॉलिड एक्सल इस व्हील के साथ कनेक्टेड होता है, जिसकी वजह से क्या होता है कि सॉलिड एक्सल का भी अपवर्ड मूवमेंट होता है। तो फ्रेंड्स अब क्या होता है कि जो व्हील के अपवर्ड मूवमेंट की वजह से फोर्स जनरेट हुआ है तो ये जो फोर्स है वो ट्रांसफर होगा कॉरेस्पॉन्डिंग राइट व्हील में। अब ये इसलिए होता है क्योंकि जो दोनों व्हील है वो आपस में लाइव एक्सल की वजह से डायरेक्टली कनेक्टेड होते हैं, ठीक है। अब इसकी वजह से क्या होता है कि स्लाइटली जो राइट व्हील होता है डिपेंडेंट सस्पेंशन सिस्टम में लीफ स्प्रिंग का यूज किया जाता है। यहाँ पे मैंने यहाँ से लीफ स्प्रिंग को दिखा रखा है। तो अब क्या होता है कि जो रोड बम्प के वजह से जो शॉक प्रोड्यूस होता है उसे लीफ स्प्रिंग एब्जॉर्ब कर लेता है और इसे यूज किया जाता है एक्सल और व्हील के बीच में। अब जब भी ट्रक रोड शॉक को फेस करता है फेस करता है लीफ स्प्रिंग जो कि कैंसिल स्टेज फॉर्म में होता है वो अपने आ जाता है, यानी कि वो स्प्लिट हो जाता है। इससे क्या होता है कि इस तरह से रोड शॉक को एब्जॉर्ब कर लेता है और इस तरह से हमारा डिपेंडेंट सस्पेंशन सिस्टम काम करता है। अब इंडिपेंडेंट सस्पेंशन सिस्टम की बात करते हैं तो फॉर्मूला कार्स में इंडिपेंडेंट डबल डिस्क यूज किया जाता है। इसमें क्या होता है कि जो फॉर्मूला कार के चारों टायर होते हैं वो इंडिपेंडेंटली मूव करते हैं, यानी कि चारों टायर का आपस में कोई भी रिलेटिव मोशन नहीं होता है। अगर एक में कोई भी शॉक आता है, मतलब इस तरह का बम्प आता है, गड्ढा आता है, तो उससे दूसरे टायर को कोई भी फर्क नहीं पड़ता है। अब हम लोग एज्यूम करते हैं कि जो फॉर्मूला कार है वो ट्रैक पे चल रहा है और उसके जो लेफ्ट फ्रंट टायर है वहाँ पे बम्प आया, ठीक है। और इंस्टेंटली क्या होता है ये जो लेफ्ट टायर है वो इसके कॉन्टैक्ट में आता है। अब क्योंकि इस रोड बम्प की वजह से क्या होता है कि जो हमारा फॉर्मूला वन कार है उसका जो लेफ्ट टायर है वो हिट करता है, इससे उसका स्लाइटली अपर मूवमेंट होता है। लेकिन मैंने आपको पहले ही बताया कि इंडिपेंडेंट सस्पेंशन सिस्टम के जो व्हीकल के चारों टायर के बीच में कोई भी कनेक्शन नहीं होता, चारों व्हील में कोई भी कनेक्शन नहीं होता, इसलिए जो फ्रंट लेफ्ट व्हील का जो अपर मूवमेंट हो रहा है वो उसी तक रिस्ट्रिक्टेड होता है, दूसरे में ट्रांसफर नहीं होता है। अब इस रोड बम की वजह से जो शॉक प्रोड्यूस हो रहा है वो कंप्रेशर टाइप स्प्रिंग और डैम्पर और मेन फ्रेम एब्जॉर्ब कर लेते हैं। शॉक का एब्जॉर्प्शन हो रहा है वो या तो डायरेक्टली होता है या थ्रू पुश शॉट्स होता है। अब ये पुश शॉट्स क्या करते हैं, शॉक को लटकल और डैम्पर और कंप्रेशन स्प्रिंग या फिर जिसे हम डैम्पर स्प्रिंग भी कहते हैं, ये उस शॉक को एब्जॉर्ब कर लेते हैं। इंडिपेंडेंट डबल विच और की वजह से ही क्या होता है कि जो फॉर्मूला अनुसार जो ट्रैक पे तेजी से दौड़ते हैं तो वो ट्रैक को पकड़ के रखते हैं, ट्रैक को छोड़ते नहीं है। ये था इंडिपेंडेंट, तो इस तरह से काम करता है। अब ये जान लेते हैं कि सस्पेंशन क्या अहमियत है और इसे यहाँ पे क्यों यूज किया जाता है। तो डायनेमिक कंडीशन में जरूरी होता है कि व्हीकल का मेन फ्रेम और व्हील के बीच में फ्लेक्सिबल कनेक्शन हो। अब फ्लेक्सिबल कनेक्शन होने से फायदा ये होता है कि उनके बीच में आपस में रिलेटिव मोशन होता है, जिससे ये होता है कि जो व्हीकल का मेन स्ट्रक्चर है और जो अदर कंपोनेंट्स है रिलेटिवली आपस में मूव कर पाते हैं, रिजिड नहीं होते हैं। व्हीकल के मेन फ्रेम का जो ओवरऑल वेट होता है, ठीक है, जिसमें क्या आपके जो मेन फ्रेम के सारे कंपोनेंट हो गए और इवन जो पैसेंजर का भी वेट होता है, ये सारा वेट ऑटोमोबाइल का सस्पेंशन सिस्टम है उसके ऊपर ही सपोर्टेड होता है, इसलिए भी व्हीकल में सस्पेंशन सिस्टम की जरूरत होता है। व्हीकल में सस्पेंशन से फायदा ये होता है कि व्हीकल का टायर और जो रोड इनके फर्म कॉन्टैक्ट बना होता है। अब इस कॉन्टैक्ट से क्या होता है कि व्हीकल को स्टेबिलिटी मिलता है, व्हीकल रोड पे मूव करते हैं। सस्पेंशन सिस्टम व्हीकल के स्टीयरिंग सिस्टम के साथ व्हीकल को प्रोवाइड कराता है, इसका व्हीकल का करेक्ट अलाइनमेंट रखता है। इससे क्या होता है कि रनिंग व्हीकल को स्टेबिलिटी मिलता है। सस्पेंशन सिस्टम में शॉक एब्जॉर्बर्स का यूज किया जाता है। अब ये जो भी शॉक प्रोड्यूस होता है उसे ये शॉक एब्जॉर्बर्स शॉक को एब्जॉर्ब करने के लिए, इसके वजह से क्या होता है कि कॉकपिट के अंदर पैसेंजर और लगेज के लिए दोनों की राइडिंग एक्सपीरियंस होता है वो स्मूथ होता है। सपोज आज की वीडियो मैंने आपको ऑटोमोबाइल में यूज होने वाले सस्पेंशन सिस्टम के टायर, उसके कंपोनेंट्स और उसके वर्किंग सिस्टम के बारे में बताया। अगर आपको वीडियो पसंद आया हो तो इस वीडियो को इसके अलावा वीडियो के बारे में और चैनल के बारे में विचार आए तो मुझे कमेंट करके जरूर बताएं। और अगर अभी तक आपने तो प्लीज सब्सक्राइब बटन में क्लिक करके सब्सक्राइब कर लो। थैंक यू।
People assume there's only one way.
It's the term given to the system of spring. Suspension system is the term given to the system of springs, shock absorbers, and linkages that connects a vehicle to its wheels, and allows relative motion between the two. The suspension system separates the wheel axle assembly from body. A vehicle needs a suspension system to cushion and damp out road shocks, so providing comfort to the passengers and preventing damage to the load and vehicle components. The springs and other components compress and expand, as the wheel hits bumps or holes in the road. This allows the wheel to move up and down without moving the vehicle body. Supports the weight of the vehicle. Provides a smooth ride. Allows rapid cornering without extreme body roll. Keeps tires in firm contact with the road surface. Allows front wheels to turn left or right for steering. Isolates the body from road shocks and vibrations. Prevents excessive body squat, tilting down at rear, when accelerating or heavily loaded. Prevents excessive body dive, tilting down at front, when braking. Suspension system includes steering knuckle, control arm, ball joint, suspension springs, sway bar and dampers. Steering knuckle is that part which contains the wheel hub or spindle, and attaches to the suspension and steering components. The wheel hub and bearing assembly is mounted on steering knuckle. Steering knuckle is mounting with tie rod for steering, lower arm, brake caliper, and strut. control arm is a movable lever that fastens the steering knuckle to the vehicle's body or frame. Vehicles with short long arm front suspensions have 4 control arms, 2 uppers and 2 lowers. While most strut-equipped vehicles have only 2 lower control arms in the front suspension. Ball joint is chassis part that connects the steering knuckle to the control arm. The ball and socket design of the joint allows it to swivel, so the knuckles can pivot as the wheels are steered, and allows it to arc so the knuckles can follow the vertical motions of the suspension, as it reacts to changes in the road surface. Vehicles with short long arm front suspensions have 4 ball joints, 2 uppers and 2 lowers. While most strut-equipped vehicles have only 2 lower joints in the front suspension. The vehicle body is supported by the suspension springs, which are located between the body and wheel axles. There are 4 main types of springs in common use: coil spring, leaf spring, torsion bar, and rubber spring. A coil spring is simply a spiral of resilient steel rod. It is stretched or compressed by the vertical movement of the wheels. Coil springs are most common springs used in front and rear of passenger cars. Coil springs absorb the force of impact by twisting. The leaf spring is one of the oldest forms of springing. It is usually used on rear-wheel drive vehicles because of its simplicity. They are normally mounted longitudinally. Leaf springs are constructed of 1 or more strips of long, narrow spring steel. These metal strips, called leaves, are assembled with plastic or synthetic rubber insulators between the leaves, allowing freedom of movement during spring operation without creating wear or noise. The longest leaf, called the main leaf, is rolled at both ends to form eyes. These eyes are used to mount the spring to the frame of the vehicle. The leaves are held together by a center bolt that passes through a hole in the center of each leaf. Rebound clips are formed at intervals around the leaves. They prevent excessive flexing of the main leaf during rebound, and also keep the leaves in alignment. The front end of a leaf spring is mounted to a hanger, with a bolt and rubber bushings directly attached to the frame. The rear end of the leaf spring is attached to the frame with movable mounting hangers called shackles. The leaf spring is also used to locate the axle on the spring. The axle is then clamped to the spring by U-bolts that wrap around the axle housing and through a spring plate underneath the spring. Torsion bar is a straight spring steel rod with splined or square ends. One end of the bar is attached to the frame, and the other end is connected to the lower control arm. The torsion bar twists around its center as the control arm is deflected. Non-metallic materials like rubber can provide the main springing action, but are more commonly used as stops to limit extreme suspension movement. The stops can also be shaped to provide an auxiliary springing function in light vehicle applications. Bump stops can help cushion the suspension and prevent it from bottoming out. Bump stops are made in a few different designs, so they mount in different places. Some are placed in line with the piston rods of shocks, others mount between frame and axle, absorbing impact before the axle gets a chance to slam into the frame.
Okay, we'll come back to our presentation.